Welcome back to AI Tech Hub. I'm Cody. If you've spent, any time at all working in tech, or honestly even just reading about modern software development, you have absolutely encountered a massive buzzword that gets thrown around constantly. Yep, I'm talking about Kubernetes. It has a notoriously steep learning curve, and let's be real, the documentation alone is enough to make your head spin. It sounds deeply intimidating to a lot of developers, almost like this mystical black box of infrastructure that you need a PhD to figure out. But today, we're going to strip all that complex jargon away and break the core concepts completely down in this explainer.
So what exactly is Kubernetes? And why is practically every tech giant on the planet relying on it? It's definitely not just a passing trend. There's been a massive, fundamental industry shift toward this technology over the last decade. It went from this highly specialized internal Google project, they called it Borg, to becoming the absolute bedrock of modern cloud computing. I know it seems like a massive, complex mystery right now, but I promise you, by the end of our time together today, you're going to understand exactly how it works. And to do that, well, actually, scratch that. We're not even going to look at code. We're going to step entirely away from servers and software for just a minute.
I want you to picture a massive, real-world shipping port. Really try to visualize the immense scale of it. We're talking about hundreds, maybe even thousands of massive physical steel shipping containers. And they are constantly coming and going 24 hours a day. Millions of tons of cargo moving through these spaces on a daily basis. They're getting loaded onto these massive cargo ships by giant cranes. They're being moved to different docks, unloaded onto trucks, and stacked literally miles high. The sheer scale, the logistics, and the pure chaos of a bustling physical port is honestly staggering to even think about.
Now imagine trying to manage all of that movement completely by hand. Imagine a team of people trying to manually track all of this. Step 1 would be teams walking around with clipboards, writing down exactly which steel container goes where. Step 2 would be people physically walking acres of concrete, just checking if any of these giant steel boxes got damaged in transit. And Step 3 would be frantically trying to find and swap in replacements when something inevitably goes wrong. If humans had to do this manually, logistics would crash to a halt immediately. And for anyone who has been in tech long enough, this physical nightmare, that is exactly what the old days of system administration felt like. Back when engineers had to manually SSH into individual physical servers at 3 a.m. just to reboot a broken application. So how do modern shipping ports actually survive this logistical chaos today? Well, they certainly don't rely on clipboards and human memory. The port utilizes a highly advanced automated operation system. This acts as a centralized brain for the entire port, managing everything efficiently without a human operator ever lifting a single finger. It takes the human error, the delays, and that impossible physical labor completely out of the equation. Chaos is beautifully transformed into this smooth, self-governing ballet where everything simply works exactly as intended. What that automated system is doing day and night is essentially the holy grail of operational management. It tracks every single container continuously, so it knows exactly where everything is at any given microsecond. It automatically moves those containers to the docks where they are needed, right on time. And, brilliantly, if one container gets damaged or, accidentally falls off the crane, the system instantly flags it and swaps in a new one, all without anyone having to manually intervene. This concept of a seamless, self-healing operation saves massive amounts of downtime and millions of dollars in real-world shipping.
Okay, keep that perfectly automated physical port in your mind, because that brings us right back to our original question. That operation system, that is exactly what Kubernetes is. Except instead of managing big steel shipping containers, it's managing software containers, specifically what we call Docker containers. Docker containers are self-contained little packages of a software app. You take all the code, the libraries, all the specific tools your app needs to run, and you box it up into one neat, standardized package. This completely eliminates that infamous "it works on my machine" problem, because the environment inside that box is the exact same no matter where you put the container.
Let's compare the two and connect the dots here. In the physical world, you have the shipping port with steel shipping containers, cargo ships, and what would otherwise be impossible manual tracking. In our digital world, we have the digital port. The entire port itself is what Kubernetes calls a cluster. The cargo ships carrying the heavy load, those are your underlying servers, which Kubernetes calls nodes. The steel boxes getting moved around are your Docker containers, running inside what Kubernetes calls pods. And that highly intelligent, automated central brain running the whole shebang, that's Kubernetes. So what is Kubernetes actually doing for your software behind the scenes? Just like the physical port operator, it's handling all the heavy lifting. First, it decides which server or node runs which container for maximum efficiency. Second, if a software container crashes, which, let's face it, happens all the time in the real world, Kubernetes instantly restarts it or swaps in a fresh one to maintain that self-healing environment. And third, it handles dynamic scaling. If you run an e-commerce app and suddenly get hit with a massive wave of Black Friday traffic, Kubernetes automatically scales up, spinning up new pods to handle the load so your site doesn't crash. And then, when the traffic subsides, it scales them right back down to save you money on server costs.
The absolutely crucial philosophy behind all of this is captured perfectly in this idea. You tell Kubernetes what you want running, and it keeps making that true, constantly, in the background. This is what the tech industry calls a declarative system. Instead of giving the computer a step-by-step, imperative list of instructions on how to start an app, you just declare your desired state. You just say, hey, I want exactly 5 copies of my app running. Kubernetes acts just like a thermostat in your house. If a server dies and you drop to 4 copies, Kubernetes immediately notices the room got too cold, so to speak, and spins up a 5th one somewhere else to maintain that reality.
So the next time you hear developers throwing around complex jargon about clusters, nodes, and pods, just remember the fundamental concept we've covered today. It's not magic, and it definitely doesn't have to be an intimidating black box. It is simply a remarkably smart port operator for your software. It is taking what used to be a chaotic, manual, logistical nightmare for system administrators and automating it beautifully into a resilient, self-healing system.
Which leaves us with this final thought. Think about the applications you rely on every single day. The 4K video streaming services, the massive global social networks, the banking apps handling millions of simultaneous transactions. Consider how modern cloud computing could even exist without this invisible orchestration working flawlessly in the background. The reality is, the modern web as we know it simply couldn't function at this scale without it. Thank you so much for joining me for this explainer. If you want to keep untangling the tech world with us, make sure to follow and subscribe to AI Tech Hub. We break down a new concept in every explainer, and I'll catch you in the next one.